Hello everyone, welcome back to our YouTube channel. So we have started a series on operational research in which in the previous lecture we have completed dichotomous search method. So in today's session we will be completing the second method of sequential search technique, which is Fibonacci search method. Okay, so let us start. Fibonacci search method is an optimization technique which is used to optimize a unimodal function with the help of Fibonacci numbers. Okay. Second important point is optimization can be either maximization or it can be minimization. So we can either maximize or minimize a unimodal function with the help of Fibonacci numbers. This particular method is called as Fibonacci search methods. Okay. Next, the Fibonacci numbers are represented in terms of Fn, where f represents the Fibonacci and n represents the position of number whose Fibonacci series is to be found out. And the generalized formula for Fn is Fn equals to Fn minus 1 plus Fn minus 2. So let us write down some useful Fibonacci series numbers. So F0, that is Fibonacci of 0th position, is always 0. Fibonacci of the first position is 1. Now, Fibonacci of the second position is the addition of previous two numbers, because the standard formula is n minus 1 plus n minus 2. So F2 is 1 plus 0, that is 1. F3 is 1 plus 1, that is 2. F4 is 2 plus 1, that is 3. F5 is 3 plus 2, that is 5. F6 is 5 plus 3, that is 8. F7 is 8 plus 5, that is 13. F8 is 13 plus 8, that is 21. F9 is 21 plus 13, that is 34. F10 is 34 plus 21, that is 55. F11 is 55 plus 34, that is 89. F12 can be calculated as 144. F13 can be calculated as 233. F14 can be calculated as 377. F15 as 610. F16 as 987. F17 as 1597, and further we can calculate the Fibonacci series till whatever values we are supposed to or required to solve the numericals. Okay. Now, apart from that, in the numerical, the accuracy by which the problem is to be solved will be given. So there is one generalized formula: 1 upon Fn should be less than or equal to that accuracy. So this is the one formula that we need to be keeping in mind. The second important formula is I0 star. Now I0 star is the point, or it is a distance actually, on that particular interval where we plot certain points. So the value of I0 star is I0, that is interval, into, in denominator we have Fibonacci n, and in the numerator we have Fibonacci n minus 2. Similarly, in the next iteration we will require I1 star. So again I1 star will be I1. Now in denominator we have Fn minus 1, and numerator we will be having Fn minus 3. And likewise, we can again calculate I2 star as I2 into, in denominator we have Fn minus 2 and in numerator we will have Fn minus 4. Okay, so let us understand these particular formulas and the Fibonacci series with the help of a numerical. The numerical is of maximization. So we are supposed to maximize a function, and the function is given by f equals to 16x minus 0.2 x square within the interval. So interval is given as 0 to 100. Okay, and accuracy is given as 0.1%. So please remember, accuracy is given in percentage. So let us begin. So the first formula that we will be using is 1 upon Fn should be less than or equal to accuracy, which is 0.1. As it is represented in percentage, we will write 100 in the denominator. So now we have 1 upon Fn should be less than or equal to 0.001. We will take the reciprocal, and we know that while taking the reciprocal, the sign less than or equal to will become greater than or equal to. So now the reciprocal of 0.001 is 1000. So in this numerical, it is evident that the value of Fn should be just greater than or equal to 1000. So let us refer our series. So now we have F17, the value of F17 is greater than or equal to 1000. If we consider F16, it is 997, which is less than 1000. So now for us, this F17 will be Fn, F16 will be Fn minus 1, F15 will be Fn minus 2, F14 will be Fn minus 3, and likewise. Okay, so let us start with the first iteration. Number 1, first iteration. So interval I0 will be 100 minus 0, that is 100. Okay. Now let us plot a graph. Let us plot a line where left side interval is 0 and right side interval is 100. Consider 2 points x1 and x2 placed at a distance of I0 star from the either ends, and I0 star is I0 into Fn minus, we can refer this formula, Fn minus 2 upon Fn. So I0 is 100 into Fn minus 2 is 610 and Fn minus 1 is 1597. So 610 divided by 1597. We can solve it. Thus I0 star that we are getting is 38.2. Now mathematically, we can get the values of x1 as 0 plus I0 star and the value of x2 as 100 minus I0 star. So putting it in the equation, we have x1 and x2 as 38.2 and 61.8. We can put these value in the function which we are supposed to maximize. Thus we will get f of x1 equals to 319.35 and f of x2 equals to 224.95. Now interpretation is very much important. We can write f of x1 is greater than f of x2. So whichever will be smaller can be eliminated, as the problem is of maximization. Thus we can eliminate the minimum value. So we can write down the portion to the right side of x2. So area to right of x2 can be eliminated. Okay, so this portion can be eliminated, as here value is already less than, that value is already less than f of x1. So now we have new iteration, and that new iteration is from 0 to x2, that is 0 to 61.8. So consider second iteration. New interval I1 is 0 to 61.8. Therefore, I1 will be 61.8 minus 0. 61.8. Okay. Again, we can plot a new interval, and that new interval is 0 and 61.8. Now we can mark 2 points x3 and x4 which are situated at a distance of I1 star from the either ends. And according to our formula, I1 star is given as I1 into Fn minus 3 upon Fn minus 1. Okay, so the value of I1 is 61.8, the value of Fn minus 3 is 377, and Fn minus 1 is 987. So we can put the values here. 61.8 into 377 upon 987. Therefore, we have I1 star equals to 23.60. Okay. Now, mathematically, we can calculate x3 and x4. So, x3 will be 0 plus I1 star, and x4 will be equal to 61 minus 0.8 minus I1 star. So, value of x3 and x4 that we are getting is 23.60, and x4 is 61.8. Let us put this value in the function to get f of x3 and f of x4. Okay, so if we put, we have f of x3 as 266.21 and f of x4 as 319.35. Again we can compare. So f of x4 is greater than f of x3. So we will eliminate the area which is minimum, because the problem is of maximization. Okay, so now we can eliminate the area. We can eliminate the area. Eliminate the area to left of x3. Okay, so this area will be eliminated. So the new interval will be from x3 to 61.8. So now we have third iteration. New interval I2 will be from 21.60 to 61.8. Okay, so similarly I2 will be 61.8 minus 23.60. So now we are getting I2 equals to 38.2. Let us again plot this interval. So we have 23.60 and 61.8. Let us consider 2 points x5 and x6, which will be situated at a distance of I2 star from the either ends. We have I2 star will be equal to I2 into, in the denominator we will have now Fn minus 2, and in the numerator we will have Fn minus 4. We already know the value of Fn minus 2 and Fn minus 4. So let us put those values. So 38.2 into 233 upon 610 Thus I2 star equals to 14.59. Okay, so mathematically we can calculate x5 and x6. x5 will be 23.60 plus I2 star, that is 14.59. The value is 38.19, and x6 will be 61.8 minus I2 star, that is 14.59. Thus the value is 47.21. Okay. Similarly, we can find function of x5 and the function of x6. So the values that we are getting here is 319.34 and 309.62. Again, we can write it down. We can write down that f of x5 is more than f of x6. So therefore, we can eliminate area to right of x6. So this area will be eliminated and we will get a new interval. Okay. So we can calculate the iterations unless and until the value of both the points are similar. Okay. Or else we can stop after 3 to 4 iterations. If we solve this problem up to 5 iterations, so the points at the 5th iteration will be x9 and x10. If we solve this numerical, the value of x9 that we are getting is 38.19, and the value of x10 that we are getting is 41.64. Therefore, f of x9 and f of x10 will be 319.34 and 319.62. Now see, the value of these two functions is almost same. So we can stop at iteration number 5. We can take the average of both the values. So we can write down the optimum point is, optimum point x star will be the average of x9 and x10. So taking the average of 38.19 and 41.64, the answer of x star is 39.91. So we have found the optimum point, and if we put this value in the given function, the value of f of x star is 319.99. Okay, so this is the maximum value. If we compare this value with all the previous value that we have got, 319.62, 319.34, 319.34, 309, similarly 266, 319.35, 319.35, 224.95, etc. So if we consider all these value, obviously the maximum value is 319.99 and the corresponding point is 39.91. Okay, so I hope you have got what exactly is Fibonacci series method, how the optimization is done, and how the Fibonacci numbers plays a very important role in optimizing it. In the next session, we will solve one more numerical which will be of minimization with the help of Fibonacci search method. Thank you very much.